One of the first steps to understanding regulation of the internet and governance of the internet is to understand the architecture of the internet, at least at some level of abstraction, that we can get our minds across what the limits of government action and private regulation of the internet are. So Dan Gilmore famously said that the net treats censorship as damage and roots around it. And that quote shows that the internet is designed to be resilient to control or failure at any point along the interconnected series of networks. So to understand this claim, we have to understand the internet as a series of interconnected networks around the globe, connected between private, commercial, educational, institutional, publicly owned, and even military networks around the globe, connected up into this massive web of interconnected mess. This network of networks connects billions of people around the world. So the internet you can think about as a connected series of networks, or a network of networks that connects billions of people, all communicating over one standard protocol, the Internet Protocol. And it's the Internet Protocol that enables all of these networks to talk together and to work together to enable messages to pass from one end to another end of the network, whether that is in the same room or across the world. The internet as we know it was built on investments in technology and infrastructure by the US Department of Defense, the DARPANET, and investments by academic institutions in the US from the mid-60s onwards. Eventually, from the 1990s, the internet was opened up to commercial investments, and other people private companies and governments started to invest heavily in laying new pipes, creating new networks, connecting more and more, ever more people to this global network. So in this structure, anyone can connect to the internet. The internet is designed to be open and essentially dumb network infrastructure. There's a lot of smarts that go into advanced routing that mean that the networks or the systems that control how messages get from one place to another need to have very complex systems in place to actually make sure that packets get received. But they don't care about the content. So the infrastructure of the internet is designed to be agnostic about what content it's carrying. And anyone can plug into the internet and send things from point A to point B, wherever those points might be. This is one of the reasons behind what we call the generativity of the internet, its capacity to foster innovative services. The internet, as a system of interconnected networks, is agnostic about what services and communications are provided on that infrastructure, which means anyone can create new services without having to get permission or change the underlying infrastructure or network protocols. They can immediately plug in and start delivering new types of content. They can start speaking or hosting content from all over the world and interacting with people in new ways. And this allows a huge amount of innovation that we've seen over the last 20 years as the internet has exploded in the different types of things that people can do as they communicate online. So when systems communicate on the internet, those communications are broken down into small packets of information. And the infrastructure that the internet provides routes those packets the best way that it can to get to their destination. So for example, when a user in Australia requests a web page from facebook.com, that request is broken down into tiny little packets and flows maybe 10, 20 different hops or between 10 or 20 different network links as it's passed around Australia from a consumer ISP to a large national backbone to a transnational undersea cable to a US-based backbone to a US hosting provider and eventually to a web server owned and operated by Facebook. Facebook gets that message and sends the results, the web page in response to that request, back to the user, not necessarily over the same path. The network will decide which path is best for those communications to follow. And the packets can be split up and go in divergent paths. What this means, this packet switching technology, is that unlike a telephone network, you don't need to create a static connection between 2 points who want to connect. You can leave that open to the network to figure out how to route packets from one end to the other, which means that if there's a problem in the network along the best path, for example, it's easy for the packets to be routed around a failed network link. And in that way, the internet routes around damage. So Dan Gilmore says that this is what makes the internet resilient not only to damage, but also censorship. That when governments or private firms attempt to remove material from any one source, there are many different channels for that material to be hosted and communicated in order to get around the block that is imposed by the censors.